Hello students, in this video I would like to discuss some properties of differentiation, and this is the syllabus of Karnataka University BSc 4th semester Mathematics paper 2 Vector Calculus and Differential Equations. Now after learning of this session, students should understand that is the differentiation of vectors and also properties of the differentiation of vectors. And first of all, I would like to discuss the derivative of a function with respect to a scalar variable t. Let us take R be a vector function of a scalar variable t. Then its changes in R means small changes in R. It means that is R plus delta R is again that because R is depends on t there, so that t also changes, small changes in t there, that is t plus delta t. It is f of t plus delta t. And just let us be called it as equation 1 and 2 respectively, subtracting these two. So then we got it, that is r plus delta r plus minus r. It means f of t plus delta t minus f of t. So r gets cancelled each other, delta r remains, and next we can dividing throughout by delta t. Then it means delta r by delta t equal to f of t plus delta t minus f of r by delta t. And then we can take a limit on both sides as delta t approaches to 0. Then which gives, that is the limit of delta r by delta t as limit delta t approaches to 0 is limit of f of t plus delta t minus f of t by delta t as delta t approaches to 0. These f of t is the vector function of a scalar variable t there. Then this limit of delta r by delta t as delta t approaches to 0 can be taken it as dr by dt there. So then here, if the limit of the right hand side exists, then limit of the left hand side, that is a limit of delta r by delta t as delta t approaches to 0 is called the derivative of a vector function of a scalar variable r with respect to a scalar variable t, and which can be denoted by dr by dt is equal to limit of f of t plus delta t minus f of t divided by delta t as delta t approaches to 0. This is which we have called it as a derivative of r with respect to t is limit of f of t plus delta t minus f of t as divided by delta t as delta t approaching to 0. Next, similarly we can see that is a derivative, a second derivative of this first derivative is, that is r and dr by dt is also called that is a vector function of a scalar variable t. If dr by dt is differentiable, it is called the second derivative of r, and it's denoted by d square r by dt square. And you can differentiate that second derivative, you will get a third derivative. So derivative of r of a scalar variable t there. So that is d cube r by dt square, and so on. And also we have properties of this differentiation of a vector function of a scalar variable t, and phi b a differentiable scalar function of a same scalar variable t, but where a and b are two differentiable vector function of a scalar variable t. So then see that d by dt of two vector functions, sum of two vector functions is equal to the derivative of the first vector function with respect to t plus derivative of the second vector function with respect to t there. So, and similarly for differentiation of subtraction of two vector functions is again that differentiation of first vector function with respect to t minus differentiation of the second vector function with respect to t. And also similarly, that is a differentiation of the product of two vector function is nothing but the differentiation of the first vector function into the differentiation of the second vector function. And likewise, differentiation of the cross product of two vector function is again that is the differentiation of the first vector function cross of that is differentiation of second vector function. It means what? Differentiation of the cross product of two functions vector function is equal to the cross product of differentiation of two functions, that two vector functions. That means what? Here it is the differentiation of this d by dt of a cross b plus a of t cross d by dt of b t. And last one, d by dt of this scalar functions into vector function is equal to the scalar function into the differentiation of the vector function plus differentiation of the scalar functions and then vector functions multiplied together. So we'd like to discuss the proof of this each properties of this differentiation of differentiable vector function of scalar variable t. And here that is the first one, differentiation of the sum of two vector functions. So let us take given a and b are two vector functions of a scalar variable t, and phi be a differentiable scalar function of same scalar variable t. Let f of t be scalar functions that let us take, that is a of t plus b of t, and small changes in this function that is of a scalar variable t, that is f of t plus delta t. Same thing can be changes in, that is the a of t plus delta t plus b of t plus delta t. Then by make use of the definition of derivative of a vector function, see that d by dt of a vector function is equal to, that is the limit of f of t plus delta t minus f of t divided by delta t as delta t approaches to 0. Just we can make use of this here by taking, as we have taken here, that is f of t is f of t plus delta t is f a of t plus delta t plus b of t plus delta t. Then minus, that is f of t is a of t plus b of t divided by delta t. Just by grouping, that is the, again I wanted to make is as that is the definition of derivative here. So then see, that is a of delta t minus a of t limit as delta t approaches to 0 plus b of delta t plus minus b of t divided by delta t, that's limit of this, and taking the individual limits of this here, applying that, and limit of a of t plus delta t minus a of t divided by delta t as delta t approaches to 0 is t of dt of t, plus limit of b of t plus delta t minus b of t divided by delta t as delta t approaches to 0 is d by dt of b of t. And then that means what? D of this f of t is what here? That is a of t plus b of t. D by dt of differentiation of sum of two vector functions with respect to t is, that is the differentiation of the first vector function with respect to t plus differentiation of the second vector function, that is with respect to t there. That means d by dt of a plus b is nothing but d by dt of a plus d by dt of b there. That means derivative of the sum of two vector functions is equal to the sum of the derivatives of two vector functions. So similarly we can see, that is the differentiation of the that is d by dt of the subtraction of two vector functions is equal to that is differentiation of the subtraction of individual vector functions. That and next, a third property we wanted to prove, that is the differentiation of the product of two functions. Here, by taking that, let us take that is f of t is a of t into p of t. These two are the vector functions, and small changes in this vector functions as t plus delta t, it is a of t plus delta t into p of t plus delta t. Small changes in t, that scalar vector. So then, by make use of the definition of the derivative, here that is d by dt of f of t is where f of t is the product of two functions, two vector functions. So then now we can make use of this definitions here, derivative, and replace that is f of t plus delta t by this a of t plus delta t into p of t plus delta t, and f of t replaced by a of t into p of t divided by delta t, and then you can make use by taking that is the a of t plus delta t in b of t plus delta t minus a of t plus delta t into p of t plus a of t delta t means what? Keep remember, here we can have an adjustment with some plus and minus term of that a of t plus delta t into p of t plus a of t plus delta t into p of t. Add and subtract by this term, and then you can grouping the term like this by taking that is the common term between these two terms, it is a of t plus delta t, and take this one and b of t plus delta t minus b of t, that, and here in the second term it is p of t is common there, and by taking it is the individual term of limit of this individual terms, and then it makes it as that is the it is a of t plus delta t, it is what which we called it as that is the a of t itself, that is a d by dt, limit of this is nothing but a of t itself, and this is what it is, the d by dt of p of t there, and it is a b of t again which we have there, and then we have this common term, that is the d by dt of this a of t there, and then which we called it as that is the differentiation of the product of two vector functions is dot product of two functions is nothing but a of t dot product of a of t into differentiation of p of t plus dot product of b of t into differentiation of the a of t with respect to t there. That is what there. And similarly, cross product of two vector functions we have derived here. That is a cross. Let us take that is f of t is a cross b there. That is a and b are vector functions, and small changes in that we can take it, that is again cross product of small changes in t in that functions. Then we can make use of that is definition of the derivative. We can have that is arrive at that is the differentiation of the cross product of two functions is nothing but that is the differentiation of the two vector functions plus a cross of differentiation of second vector function. And similarly, we can have that is the differentiation of d by dt of scalar functions into vector functions. Arrive at that is it is the f into differentiation of the scalar functions with respect to t plus phi into that is scalar functions into differentiation of the vector functions with that. And then derivative of a function of a function, let r be a derivable function of a scalar variable s, and s be a derivable of a scalar function of another scalar variable t, then r is a derivable function of t. So that means what it is the dr by dt is nothing but that is dr by ds into ds by dt. That r with respect to scalar variable s and scalar variable with respect to vector that another scalar variable t. Constant vectors, vector function is said to be constant if both its magnitude as well as direction does not change that. That is, for example, this one. A vector will change if either its magnitude changes in direction, both magnitude as well as direction changes. Thank you. And